Now we're going to finish this section with the levels of measurement, where we're going to look at them from least to most descriptive. That is, from having the most information given by the category to having the least information to the most information. Excuse me. Too many videos in one day leads to some silly mistakes in speaking. Anyway, we'll start with the nominal level of measurement, which, like I said, statisticians are very creative. It means we're looking at names. That is, when we look at nominal data, we're just looking at labels. We're looking at things like a color or a blood type, that my blood type is O positive. There's no value attached to that. There's no comparison attached to that. It's just a thing. We can think of nominal data as being purely qualitative. Next, we have ordinal data, where we are attaching labels, we are attaching names, but those names have an inherent order to them. So if we're thinking about ordinal data, we're thinking about something like a letter grade, where when we're looking at a letter grade, there is a clear hierarchy from F up to A, where a D is better than an F, but worse than a C, B, or A. However, when we're looking at things that are ordinal, what we have to understand is that the order there doesn't really have a fixed range in any sense to it. Yes, you could add more to letter grades to give them that fixed range, but as they are by themselves as something that is strictly ordinal, they don't. Going from a D to a C just as those letters is in some sense an infinite change, because it's one fixed point to another. That's one of those defining characteristics of ordinal data, is it's just these fixed comparable points. As D to C is the same no matter what D it is, no matter what C it is, and you can't talk about D to B as being a greater change than D to F, because you don't quite have the same context for comparison. To get that context, you go to the next level and we talk about interval data, where for interval data, we are going from names in order to names, order, and consistent ranges. But there's one thing that's missing with interval data that I'll talk about in a second. But really, the defining thing here is that there is a sense of consistency between the change within values in interval level measurements. So the classic example that you always see when you're talking about interval things is temperature scales. Because when you're looking at that, you can compare 40 degrees Fahrenheit.
Ain't nobody got nothing to say about a 40-degree day.
To 80 degrees Fahrenheit.
50. Bring a smile to your face.
And understand that at every single point in the middle there, you have more that you can compare with. The entire interval is meaningful value, and that 40 degrees is consistent. If I look at the comparison from 40 to 80 and then compare it to the difference between 60 and 100, it's the same range, it's the same interval. It has the same meaningful difference between those pairs of points. And then if we want to take it one level further, we can go on to ratio. When we're looking at ratio data, we have names, we have order between the names, we have a range between the values, and we have a meaningful true zero. We also get ratios of values, but ratios of values are a bit harder to quantify. It's easier to think about things in terms of that true meaningful zero, where thinking about temperature, if you have the value 0 degrees Fahrenheit or 0 degrees Celsius or even 0 degrees Kelvin, well, maybe it it does in the Kelvin scale, but that's theoretical. Anyway, with most measurements of temperature, if you say it is 0 degrees, you are not saying that the room lacks a temperature. You're saying it's cold. And you're saying it's cold that in a way is warmer than -10. But again, -10 doesn't mean that there is 10 less than nothing heat. It just means that it's cold. 0 is just a point on the scale that we can go above, we can go below. It doesn't have a special meaning or value to it. Whereas with something that's ratio level, something like height, for example, that 0 has a meaningful value. 0 inches indicates a complete lack of height. In the same way that if we go from a letter grade to a point system, a grade of 0 doesn't just indicate a bad grade. It indicates that you have earned no grade, that you haven't earned a single grade throughout whatever it is that you're looking at. It shows a lack. It doesn't just show a small amount, it specifically shows no amount. And when you're thinking about these measurements, these levels of measurement for data, the way that a lot of people like to keep it in mind about this order from least to most descriptive, as it were, from least to most information, is thinking in terms of the French word for black, N-O-I-R, noir. So I guess if you're a fan of old movies, whenever you're having trouble coming up with this acronym here, just think of Bogey and Bacall.
No. He's looking at you, kid.
And it'll come right back. And we'll finish this section with an example on how we can make these distinctions.